Welcome. In this video, we're going to explore finding solutions to different functions using a table. So let's use this table to find a solution to the system of two equations. And remember, when we write out a solution, we have to write out both the x and the y value. And I'm going to show you how to also write it out as an ordered pair. So this x is shared by both functions. That is, an input of -3 has an output for f of 12. Similarly, this column is telling us that for g, an input of -3 has an output of 10. Now, this is considered a prerequisite to this course, so I'll just continue. But in case you don't remember, this is what this function notation is telling us. So f of 0 is 3, but g evaluated at 0 is 4. And so what you're looking for any places here that match or maybe come really close to matching. And we'll get more into that in the next example. For now, are there any spots that match? Here, both f and g have an output of 6. So f of -1 equals 6, but g of -1 also equals 6. So the solution is x equals -1, y equals 6. And as an ordered pair, we have -1, 6. We can also estimate the solution to a system of two equations using a table when the precise solution, so the precise value of the solution, is not listed. So the table below shows the population of two fictitious towns over a number of years. So we have town A and town B. And I'm going to make a little sketch, so I'm going to go ahead and put a blue asterisk near town A and an orange asterisk near town B. And you'll see why I'm doing that in a second. So an input of 0, so that's the number of years after January 1st, 2000. I want to add, if you were to graph this and write 2000 on your x-axis here, you'd be wrong, because then you'd be in the year 4000, saying it's been 2000 years after the year 2000. So remember, this specifically says the number of years after 2000. If you're standing in January 1st on the year 2000, and 0 years have elapsed, then you're still in the year 2000. All right, now that said, in 2000, town A had 2,500 people, and then it goes up to 3,037, and if you notice, it keeps getting larger. So this population is increasing. Now let's look at town B. For town B, we start off at over 10,000, then it suddenly drops to 9,500, and if you notice, the population is just getting smaller and smaller. So what we know is population A. So what we know about population A, we can represent here in this little mini sketch I'm creating. So for population A, its population is increasing. So it starts off somewhere here and it just goes up. And for population B, it's decreasing. So it starts off pretty high and ends up there. And now these are just rough sketches. It's not meant to be exact. It's just meant to give me an idea of what's happening. So in the year 2000, the population of town B is larger. And then at some point they're the same. Then if you notice, the blue line is on top. So that tells me at some point the population of town A is larger than town B. So take a moment and on your own, go ahead and write down which one has a larger population. For example, here I know population A is less than the population of town B. Okay, A population is less than the population of town B. If I were to go all the way here on the right, the population of A is larger than town B. So on the right, we're kind of in this section. And on the left, we're in this section. So take a moment and fill in these little gaps in this table with these inequalities. And what you'll notice at some point, you'll have an A less than B, and then the very next one will be A greater than B. And that's what we're looking for. We're looking for where this transition happens. So please pause the video and try this on your own. Okay, now that you've paused your video, you should see what I see here. I see population A is smaller, and population A is still smaller until we get here to 2016. So somewhere between 2013, so this is the year 2013, and the year 2016, the population of A went from being smaller than the population of B to then being larger than the population of B. So let's write down a solution for part A. And since this handout lacks in space, I'm going to do it down below. Somewhere between x equals 13 and x equals 16, the system of two linear equations intersects. If you noticed, I went ahead and erased the word linear. I haven't verified that this is linear, and I'm really not going to do that right now. What matters is the intersection. So somewhere between x equals 13 and x equals 16, the system of two equations intersects. This means that the population of towns A and B were the same sometime between 2013 and 2016. Now for part B, in a normal class, I would ask you to turn around and chat with your neighbor. And even in a normal class environment, I cannot force anyone to participate that does not want to. But again, to use the gym analogy, I can't force anyone to go to the gym and get on a treadmill either. So you can stare at the treadmill, or you can find someone, find a family member, find a friend, go onto the Canvas discussion forums, the optional part, and explain to someone in your own words how we could find a solution to part A. I'm not going to go over it because I just did go over how to find a solution in this entire video. Now you need to exercise your thinking muscles, your brain, and figure out how you would explain to someone how we found this estimate. So I really hope you'll do this. It is beneficial for you to do this, since if you can explain something to someone, you clearly understand the content well. Hope this video was helpful.